Good morning, everybody. My name is Jamel Saadaoui. I am a full professor of economics at the University Paris 8. I am also a researcher affiliated to the Center for Applied Macroeconomics in a Center for Applied Macroeconomic Analysis, the CAMA. So you have here my website, and you can find some materials for your research in this website. I have a YouTube channel, which is called as my website, Econ Macro, and you can find some videos of my presentation, some workshops that I did and training that I did previously during the previous months. Today, this video will have an objective to continue what we started with this video, which was called Sign and Native Restriction in SVAR with Stata. So today we are going to cover two blocks. This one, where we are going to save and plot the structural shock series. So the first block will be devoted to the Blanchard-Quah decomposition. And the goal will be to reproduce the picture that I have in the back as my wallpaper here. So all the codes are available here. So feel free to reproduce them. We're going to use Stata. Stata is not the most popular package for time series analysis. R and MATLAB are most frequently used, but Stata with his computational version MATA can also be used quite nicely. So we are going to cover that one. And about the second part, we are going to combine sign and native restriction, which will be estimated with a Bayesian technique. And then we are going to recover the residual structural innovation, but of course, as we will have many draws, you have to select one draw to plot. And you can investigate all the draws, all the accepted draws, because sometimes your sign restrictions are not accepted by the algorithm. That's also a question that could be investigated. So you have these two blogs, which can give you more background on what we are going to do today. So we are going to focus on the practical part, which is the aim of my blog. All of these codes are available on my GitHub. You can go to Econ Macro blog and then navigate a bit. You have here a table of content. So if you go to SVARs, I tried with RATs. I also tried with Stata, but it should be somewhere. I have to locate it. Sign and bar restriction with Stata. So the codes are here, and the new codes will also be added. So let's start first to try to replicate this figure, which is the standard Blanchard-Quah structural shocks. Or permanent shocks are shocks that are able to change permanently the level of output, and transitory shocks, these are shocks which are not allowed in the restrictions to affect permanently the level of output. That's the classical decomposition between supply and demand shock. That's the definition. Supply shock can be defined like that, as the shocks that will affect permanently level of output, and demand shock only in a transitory manner. So let's start with the first, the Blanchard-Quah restriction, so long-run zero restriction. So first you clear the data, and you use the data set to declare to be a time series data set. So the data set goes from the quarter of 1984 to the fourth quarter of 1987. Now, variable involved, GDP growth and unemployment. You can also look at it here. Yeah, so it's quarterly data. And you have more detail in the first block. So the example has an historical value. First, you estimate the VAR. So you have a reduced form VAR. The residuals coming from this VAR are not interpretable because it's reduced form. They combine each residual for each equation, equation 1, equation 2, combines structural shocks. So we have to separate, we have to find a way of separating these reduced form shocks and transform them into structural shocks. So you are going to make a hypothesis. Well, before going further, if you don't have the package installed, you can install it by typing ssc install, ssc install, and the name of the package. Everything is explained in the first blog that I did in the first video, so I recommend you to go to that video to see all of the previous steps. So now we are going to construct the VAR object. So BQ is for Blanchard-Quah, the VAR will be called VAR, and the options will be called OPTS, okay? So we can change option. We can save the pictures in a PNG format, 68% for the confidence band interval, and we can display all the options that have been. So let's start with that first. We're still doing Stata code here. When you use this option display, you have, okay, so identification, Blanchard-Quah, maximum of 40 quarters for the horizons. The impact is 1 standard deviation. You can also have a unitary shock. The airflows impulse response function is to 0 for compiler test is shut, 68% for the confidence interval. We have a bootstrap resampling method for impulse response function, the format of the file, and the lag. So many options. So now we are going to compute the impulse response function with a VAR, and we have an output name, which is in the Stata matrix will be called IREF. So let's go. Then we have a bootstrap, because we are going to bootstrap the confidence interval. We have to randomness. True randomness is not possible with computers, so you have quasi-randomness, so you have to set a seed. Keep the same seed if you want to have replicated results, replicable results. So most important is you compute the airfield bonds if you want. But now I'm going to focus on 2 things. The first is we are going to create a variable for the structural shock. So I recommend you to do capture drop, but on 2 lines, because otherwise it could create problems. So I recommend you to do capture drop on 2 lines here, okay? So what we have here now in the paper, we still have the data. We have some also some of the matrices were stored, but they are not yet transferred to the data. So we create these 2 variables, then drop them if they are previously created. So now 2 columns and 2 new columns appear. I have a structural shock permanently affected the level of output, and the structural shock which are transitory. Now we can close that. So keep in mind that when you have meta code, you have to run it from meta to end, okay? So first, we're going only to plot the response for the GDP growth. The bands for the impulse response function are already being computed by this guy here, okay? We're going to compute the impact matrix BQ, and we don't need to recreate it because it's already done. It is called here, and you can call it with here. So to recover the structural innovation, this is the reduced form innovation coming from the 2 equations that I showed at the beginning. You have the contemporaneous impact matrix, which embed the restrictions. And then you will have, using this formula, which is here in the blog, you are able to recover the structural shocks. So the role of this matrix, which is in the code called like that, is very important. That's the matrix that keep the restriction that you have here. And in this case, it is long-run restriction, okay? So then we are going to adjust the data because we have some lags. Remember, here we have 4 lags, so we do 4 observation plus 1 for the start of the data. Then we are going to check, of course, if the shock corresponds to the data, transfer it to Stata, and then store it into a Stata matrix. And we have some checks here to see if the computation were done in the correct way. So between mata and end, run everything. So we have an impulse response function here, and we are also going to check if the structural shock have been transferred. You know, the 4 lags are here, but that's just okay. So the shocks have been transferred to Stata from meta, then to Stata matrix, then to the data. So what we have here now, we can inspect the data, we can label the data, and then we can also look at what the matrix stores. So the row name of a matrix, so you have this matrix BQ, which is this matrix. Now, so BBQ should be, let me check. So BBQ, okay. Yeah, BBQ is store this beta one inverted. Yeah, so it just, yeah, it is this one. So that's the contemporaneous impact matrix. So you see, permanent shock has positive impact, transitory negative, permanent increase in employment, and transitory increase in employment. So this is interesting. So now we are going to see if the computation has been correct. The difference between what we have reconstructed and the computation that you can do it directly with the object is very small, is almost 0. So we are good, the formula works. Can summarize the shock. Oh, the shock has centered, 0 mean, very small, and standard deviation is almost 1. The shock should be orthogonal, and they are. So now we have just to plot the shocks here and reproduce the picture that you have behind me. Okay, so you can preserve, you can save the shock, and I think this one is not necessary because I just saved it again, I think. But you can save it here if you want. And if you do that, preserve and restore, you have to run everything between preserve and restore, and you save the data, okay? So in your folder, you will have a data set with your structural shock. And then you are free to use them if you want in the local projection setting to estimate the impulse response function. So this is quite good. This is quite interesting, actually. Okay. So now, if you, of course, if you have a question, feel free to send me an email. You can find my email here if you go back. So I'll keep that here. You can write an email. My email is here, and send me an email. I will try to answer you. So now we are going to go to this question about sign and narrative restriction of VR. It's not easy to estimate a sign restriction VR in Stata, but this with the var and underscore and R package, you can do it. So first, we are going to use a different data sets. Which is here, sorry. So the data set now is also quarterly. you have inflation, you have the Fed fund rates, and you have employment. All of these guys are in logarithms, okay, for the US economy, beginning of the 60s, at the end of the 90s, almost the first year of 2000, okay? So we can close that. So first, estimate a VR reduced form, and you had a trend. The trend is here. See, the trend seems to be significant for inflation. So inflation have a bit of a trend, a negative trend. This is the secular decline. Not secular decline, but because after the 90s and the 80s, we have this reduction in inflation. So it could make sense. So now we are going to use the same command as before, but this time you are going to use SR instead of PQ. You can call the var with a different name, for example, V and options. A linear trend we'll have also here. You can also display the options as before. So options, what is different from, look at the bonds at 95% here. You can change that if you want, but, and we are going to use bootstrap. And we have also, we can plot all the figures, that's fine. We have many options. I will not detail them very carefully, but you can do it by exploring the help of the package. I recommend you to do that. See the first video. So first, we are going to say that we have a narrative identification. Say, at the end of the 70s, we had the Volcker, Paul Volcker, who was the chairman of the Fed in the 70s. Paul Volcker, yeah, from 1979 to 1987. And he was well known for his monetary tightening with the objective to reduce inflation. So we know somehow that this restriction, this narrative restriction, will be something that we have a contractionary monetary policy innovation, which relates to what Paul Volcker did. So this is something that we know from history. This is very, very important to understand that. So it is the Volcker disinflation shock, okay? So it gives you also the meaning of a positive monetary shock, okay? So we are going to keep one draw, but keep a draw number one, sorry. But keep in mind that you can also keep the draw 500, 501, whatever. Because in the application, we will have, I think, 1,000 draw what will be accepted, okay? So first we keep that. And also this is a local, so you have to run everything. I will run everything after, okay? We create variables for the different shocks. So look at that, what is happening here. So we are created variables, shock, supply shock, demand shock, and monetary shock. What is interesting in the SV is sign restriction var, it's that it brings a bit of theory in the structural VER. In the short-run restriction, in the long-run restriction, you can make restriction by the timing. But here we are going to say how to distinguish between a supply shock, a demand shock, and a monetary policy shock. We will say a supply shock, we will have a contemporaneous restriction. Say a supply shock, in theory, should reduce inflation, should reduce unemployment. Think about aggregate supply, aggregate demand diagram, what you saw during the bachelor or at the university or before. And the federal fund rates should decrease because the neutral rate decrease if you have a supply shock. If you have a demand shock, because inflation pressure are lower, of course. If you have a demand shock, inflation will increase and employment will be reduced. Think about, the aggregate supply, aggregate demand diagrams. The federal fund rates will be increased to cope with the demand shock. Monetary policy shock should reduce inflation, primary target, then it can create more unemployment. And of course, the non-monetary policy shock will have an impact on the yield curve, and it will impact the federal fund rates. I'm not very precise on the theory because it's not the target of the talk today, so sorry for that. So you can use this MATA function, but it's not very helpful. So what will do this code? So MATA is here, and we are going to run it until it's a bit long, until here. So very briefly, I try to keep it brief. We are going to use functions, not really important for understanding. We are going to check if a draw exists. We are going to keep the draw. What we decided to keep is draw number 1. We are going to use options about identification, and we are going also sign restrictions identification. We are going to, as before, to keep the identification matrix. You can also keep the number observation and row as before to align the timing of the shock. So the name of the shock, which are here, and you can store the identifying matrices here. Okay. If you go to the blog, you will have a more detailed explanation here. So I encourage you to go. So PD is Cholesky factor for one specific draw, and QD is the accepted orthonormal rotation. Yeah. So so you will have some more detail here. So I will let you with the blog. This is quite nicely put in the blog. So we have the restriction here, plus it's a monetary policy shock here. You have the restriction, you create a sign restriction here, supply the monetary shock. So the supply shock, negative effect, deflation, negative effect on employment, negative effect on the Fed funds. So it corresponds totally to what we had did before, which corresponds to that line. So it's quite very nice here to see it in the code. Double shock, positive, negative, and positive. Monetary policy shock, negative, positive, and positive. So options, 1000 draw, update the draw, save as a PNG. You can also use a PDF if you want. So you need to set the seed, and now everything will be estimated with this function, this narrative sign restriction function. Then you can save the shock here with the keep the draw is draw number 1. Calculate the input function if you want, label the structural shock. Then you can inspect the identifying matrix. I'm going to do it before. As again, make this a construction error, correlation between the shock. And then we can also verify the narrative restriction here. And then we can make the plot, okay? We are going to run everything because we have locals. I usually don't like locals because I want to see what is happening, but we are going to proceed like that. You can also program globals, but it's a bit annoying to do it. So we have to go there. So the first local is here. So maybe we can run everything again. So boom. And then we are going to estimate it here. And we can stop, I think, before the plot, because after, oh yeah, we have to make the plot too. We still have a local here. We still have a local here. So we have to go there. So keep in mind a useful trick is if you have a local, you have to run everything until you don't have it, because otherwise it will not keep it in memory. Okay, so estimate, we will check. Maybe you could check all of these things before going to So it started the meta. So I created the two variables to store the shocks. And then, yeah, I think it's okay here. Oh, maybe I went too far. Okay, I will stop everything. Let me just clear my screen. So if you want to clear your screen, you can CLS, and if you want to clear the data, I make clear. Okay, so now everything is clean. I will just go back to here and do everything again. Okay. And then I go to until I don't have a local anymore. Sorry for that, okay? So, okay, let's go. We can do that now. So again, all of the steps after estimating the VR, you have the options. So it keeps the Volcker disinflation shock. We're going to keep the first draw, created the variables for the supply, demand, and monetary shock. Start meta. It creates a bunch of functions. SR is the identification function. You have a sign restriction. P is the choice factor of sigma, variance matrix, and Q is the accepted orthonormal rotation matrix. And we are going to focus on this inv underscore B0 for one specific draw. Align the dates because of the lag, create the narrative restriction, create the sign restrictions, very clear, set the options, and now let the draw be accepted or not. So we have narrative sign restriction because we have demand, supply, and monetary shock, plus a sign restriction for the Volcker disinflation. So we are going to look at the first draw. So we have the impulse response function, and we have now the structural shock. So let's just go to, it's already saved in PNG, so that's fine, to continue. So we have, in this example, 1,000 draw that accepts both sign and narrative sign restriction, which is good. And we have 2,000 draw that accepted sign restriction. And we have a lot of draw that have been attempted. So it's quite fast, so it's very interesting. So you can plot the ERF with this function, and you see that inflation, so you have a monetary tightening, inflation decrease in subsequent quarter, and we go back to zero, increase of unemployment, and if I go back to zero after 10 quarters, which is quite big, and Fed funds is increasing at the beginning. So quite understandable. So now we have the shocks, which have been, so you have a matrix, the impact matrix, and you have the orthonormal rotation, which is accepted for the draw number 1 here. So this is 3x3 matrix because you have 3 variables in the system. So we are looking only the first draw, and the construction error is similar. So the standard error is almost 1, and the mean is 0. The shocks are almost orthogonal, almost 0. The monetary shock is a bit correlated with the supply shock, but otherwise, demand the supply shock, a monetary tightening shock, and demand shock is almost 0. This is quite fine here. During the Volcker disinflation, we have 1.5, which is a big tightening. When you plot with test line, you plot the shock, so all the shocks. What you can see is that we see the narrative restriction, which is this Y line, X line, sorry, which is positive. So what you can see here, let's put it a bit bigger. In the 70s, you had a lot of demand shocks, the orange curve. At the beginning, at the middle of the 60s, you have also peaks, green peaks, which is supply shocks. This is only the draw number 1, so maybe you have to inspect all the draws if you're interested. And then what you can see is that the shocks were much bigger before the Volcker disinflation. Then the shocks are smaller. Is the great moderation thing, yeah? This is something that we did. The shocks were much bigger before for the US economy. So it's so the vertical line is the narrative restriction. Okay, so we almost finished. If you want, I can show you a last thing. We can look at if we select a different draw. For example, if I want to select the draw, I have 1,000 accepted draw. I can 1,000 accepted draws. I can use the draw number 5,000, 500. Sorry. Let's go do everything again. No, it's not the draw number one anymore. It's the draw 5,000. 500, sorry, I don't know why I keep talking about 5,000, I don't know. So the structural shock again, it's a bit different because it is another draw, so, but still, you see that you have a great moderation starting in after the middle of the 80s, which is visible here even. Oh, if you're interested, you can look at the draws and keep in mind that the confidence interval are computed with the distribution of the different draws. So this is what is interesting in this kind of model. So the tutorial is now finished. I hope you enjoyed it. Please consult these two blogs together with their companion. You have the update in April 2025, and you have also the initial blog in 2023, which allows you to understand each step. So first you have to read that one, and then you read that one. You can paste the data. I show you how to put the data in Excel if you're interested to put the graph in Excel, and then you can have these two last blog that I show you today to dig in a bit more into the theory of VARs, which is a very interesting theory. Of course, if you want to go further and use more complex structural VARs, you can stay on Stata, you can program by yourself, it's totally doable, but most of the package and leading authors use MATLAB, so you can try to go into that direction. Last thing, I will update this GitHub repo with my two last blogs file, and I hope it will be interesting for you. And I will also post a video on my YouTube channel. So thank you very much for your attention, and I hope you will create your own application and sign an active restriction in SVAR, which are now doable on Stata in a quite nice way. Let me conclude by thanking Abigail Kuschecke, Jona Denzinger, and Christopher Koch for their very nice work and providing this toolbox to the community. It is based on Ambrogio Cesar Bianchi from the Bank of England, I guess, VR toolbox, and use the notation of Lutz Kilian and Helmut Luchtopol in their very famous book of 2016. So thank you very much for your attention, and I hope it will help you with your application. Thank you very much.